Hello and welcome to the Rubber Duck Dev Show. I'm Chris.
I'm Creston.
And tonight, Creston's going to walk us through building some redundancy into your infrastructure without killing your wallet. I'm always interested in that. So before we do that, week in review. How was your week?
I've been juggling a lot of different stuff, seemingly. Like I was working on Rails consulting end of last week, more so, and then I had to put that to the side because then I had a lot of Postgres database consulting coming up, a lot of different calls to help people work through different issues. In terms of my own product, I actually have a marketing thing. So like any product, I need to market and get more customers. And a tool I had found that actually looks at the visitors to your site and using something like their IP address or other identifier, looks up what company they're affiliated with. So basically, it does simple Linux commands or like dig or NS lookup to find out what the domain name is for the IP address that is visiting your site. And if they're coming from an organization that owns that, you can see what the organization is. So I did a demo of one of these tools, like called Lead Feeder, but there's a fair number of other tools that do it. And I went through the trial, and then they said, okay, we estimate that you're going to be paying us $400 a month for this service. And I'm like, ouch. What? Because I haven't even gotten a whole lot of leads from it. But, my description of a lead is quite different than their description of a lead. So, for example, they basically look at who's visiting the website and they throw out any ISP IP addresses, because those are people coming in from like their home ISP, or they're in some co-working situation. They're not larger organizations that actually have particular blocks of IP addresses or whatever.
Right.
So ideally, I would like to filter it down such that, like, if they're just visiting a blog post and they leave, that's not a lead if they're not going to do anything. They're just looking for information related to that blog post, and then they're out of there.
Yeah, that's not a
They're
lead.
not really, right. They're not really looking for a solution. But of course, they charge the product based on how many leads they give you. So they want to include those leads.
No.
So, but I really like this capability to know who's visiting my website. And then, hey, if I could see this organization is visiting, I can then look up, all right, and they're looking at a pricing page. They're looking at my homepage. They're looking at the about page. Those are clearly indicators that they might be interested in my product. So I want to identify those, and then I can call. You don't know who's contacting you, but I know who I work with at these organizations. So I can just do some cold calls to say, hey, I have this product. How are you doing? How are you guys doing? It's just to strike up conversations. Now, nothing may come of it. It may not be any of the people that I call, but it's just in terms of the sea of cold calling to do, being able to target something that may have a higher probability of success is beneficial.
Yeah.
So what I did was I looked at this and it's like, this is not rocket science. So I actually have a JavaScript snippet on my website already that sends basically page traffic to my product. That's actually part of what my product does. It actually does a little bit of page tracking. And I don't do a lot with it, but it's been in place for a long time. So I said, and part of that information that gets passed is the IP address. Mm-hmm. And well, gee, there's a Ruby library called Resolver that you can look up the domain name from. And then I could implement filters to filter out the ISPs. And basically in 3 hours, I developed a system where I can look through the data that I already have and pull out the companies that are not ISPs on a daily basis. And probably with another 3 hours, I can finish up some automation. So basically, I'll get an email every day with, all right, here are the companies that have visited your website today.
And that doesn't cost you anywhere close to $400 a month, does it?
Exactly. Maybe it's 6 hours of my total time. So that was actually merging marketing to technology for that might be a win. So I'm going to see how that helps me.
Cool.
So what'd you do?
Well, our biggest client is going through a management transition on the team that I work with. So
Woohoo.
I've been kind of stuck in the project management phase of things this week a lot. Just meeting the new management over there and talking to them and building the working relationship and figuring out how they want to do things and how I want to do things. And so it's been a lot of that stuff. Had a couple little bug fixy things going on in the code, but no big fun projects this week. But that's fine. I actually really enjoy the PM stuff.
You had mentioned some of this last week. Is it that this big client, do they purposefully rotate people off, or it's just this person was just transitioning to another position and another person came in?
It's actually two people. Their PM and their product manager both rotated out a week apart. And they were moved to other positions in the company in both cases. So, but this is a huge multinational corporation. They got people moving all over the place all the time. But it just happened to be that it was the two top level folks that got rotated out at the same time, and it was just this is going to take a little bit of work and patience here. I have to spend a minute or two on this, but it's good. I'm excited about these new folks. They seem well put together, so it should be a good thing.
All right.
Huzzah! All right, so redundant infrastructure stuff. What did it teach us, Sensei?
All right. So I thought of having this topic because, imagine you have a single server that you're running your app on, and you've decided to set up on a single server. You didn't go with something like Heroku or some other platform as a service, and you're running it there. Well, what could you do to make that more redundant? Because if you have a single server, the single server goes down, your whole app goes down.
That would be bad.
So what could you do to kind of add a bit more redundancy to it? Clearly, you could move to a platform as a service or put together different services on the big platforms like Amazon or Microsoft or Google. But what could you do your own? And part of on your own. Now, part of this I'm looking at because here's some reasons I thought maybe you would want to go this route as opposed to going with Google or AWS or Microsoft. Maybe you want to be platform agnostic, because what I'm going to describe here is open source software that can give you this redundancy and show you some ways to set it up that you don't have to rely upon a platform to do it. And basically, you can move to any platform. So you could implement what I'm going to talk about tonight in any of one of these infrastructures, and the knowledge is transferable. It's not like once you learn how to use load balancers and the front end CDNs and things of that nature at AWS, it doesn't mean you can immediately go to Google and figure it out. It's a different product. They're different names. But what I'm talking about is open source software that if you do it one place, it's transferable to any other place you're using, and you can use it at DigitalOcean or Linode or any place you go.
Cool.
And the second reason to do is that just want experience to understand, all right, how does this stuff work? You know, again, it's kind of not rocket science, which you kind of learn how you can do some of these things.
Mm-hmm.
So what I'm going to focus on tonight talking about is the scenario. Imagine that you're going to be running it on AWS and you want to leverage their availability zones. So if you're not familiar with AWS, they operate within regions, and these are big areas of the country on the East and the Midwest, in the in the West. They have big regions, but within those regions, they're broken up into availability zones, maybe 4 or 5 or 6. I can't remember how many off the top of my head. It may vary by the region too, how many availability zones there are. And in theory, these zones are independent of one another and they have super fast interconnects. So they give you redundancy within a particular region, as opposed to cross regions, which have much slower latencies. So if you're going to start off with doing redundancy, the ideal way to do it if you're within AWS is to do it across availability zones. Doing cross-region protections or disaster recovery, that's a whole nother ball of wax. I'm not going to get into tonight. So the first thing you need to concern yourself with for doing a redundant infrastructure is making your DNS redundant. Basically, when someone resolves a domain name, you want to be able to go to 2 or more web servers to service that request. Now, talking again, focusing on AWS, or let me take a step back for a second. Now, I said we're going to use open source software. It's not rocket science. However, with DNS, it's a little bit of a different thing because you need a name service provider in general somewhere to get started. So it's usually best to use some sort of DNS provider for this part of it that routes, your domain name to multiple web servers.
And you're talking about the things like GoDaddy and stuff like that.
Yeah, I don't know how much GoDaddy I'm sure they have some capabilities, but there's tons of providers that do this. There's, of course, AWS has their solution, which is called Route 53. They brand all of those interesting names. Google has theirs, Microsoft has theirs, but there's Cloudflare, there's DNS Simple, there's basically any DNS provider should have this capability.
Right.
And if you want to bring up the first post, like the thing you're kind of looking for is something that's like a round robin DNS at its most base capability. So basically it's going to send to one web server. When the next request comes in, it's going to send it to another web server. Now, round robin is just one method of routing. So if you go to the next post, whoops, that would be actually the AWS post. It looks like the third or fourth one there. Yeah. So for example, AWS has all these different types of routing. So they have, sorry, it's a little bit like geo routing, failover routing, simple routing, weighted routing, latency routing. I, for example, am using Route 53, and I'm using the weighted routing policy because that makes it easy to drop the weighting to 0 to bring a web server out of rotation to do upgrades. Then once it's upgraded, you can put the weighting back, give it, the TTL, time to rest, and then you can do the other one, drop the weighting down to 0, and then do the upgrade and bring it back up. Now, the other thing about this is that you also want to implement some form of health checks. So whatever service you're going to use, you're going to want it to do health checks. And I don't have a post about that here. Do health checks against your web servers to make sure that they're up and running. So Route 53 has a built-in way to do that, to basically check a particular path on your web server. And if it responds, it considers that host good, and it can send traffic to it. If it ever fails or stops sending it, it takes it out of rotation for you automatically. And all the other DNS solutions should be able to handle that. So basically what this DNS routing does is that once it resolves to an IP, just one server endpoint is chosen, and then that client's browser always goes to that web server until the TTL is expired. And then it goes to DNS to ask for the address again, and it may get a different web server at this point. So it's conceivable across TTLs that you're going to be hitting different web servers, but it gives you a capability to have a multiple web servers backing up your application. And ideally, you would want these web servers, again, in separate availability zones. So if one availability zone fails, DNS should detect that and route you to the availability zone that's still available. All right, so that's DNS. So now let's go down to the web server. So now your web server, ideally, you want it to be able to talk to 2 or more application servers. So you still want redundancy here. Now, Nginx can actually do this quite easily. So typically in your Nginx configuration, and this is a web server, Apache has the same capability, but Nginx has the ability to define upstream backends. So basically, your web request comes in and then typically gets sent to an upstream backend that is some application server. It could be on the same box, but it could be on a different box. I personally have mine on different boxes, and it sends that request to your actual application server. And you can actually specify more than one backend. So if you look at the second post, if you could zoom in just a little bit. Okay, so you can actually specify in the Nginx configuration more than one server. And you can specify a waiting. You can specify, one is designated as a backup. I think it shows here. And if you scroll down, it has all sorts of different routing similar to DNS. So a little bit further, yeah, choose a load balancing method. So there's the round robin is, the base one. There's least connections. There's, what are some of the other ones that listed?
IP hash.
IP hash, generic hash.
Least time.
Yeah, so there's all sorts of different ways that you could route it. I'm doing, again, the simple round robin for mine, but again, you can choose to implement something different on how you want to work. And generally, those application servers, again, would be in multiple availability zones. So if anyone happens to fail, it'll fix it. Now, again, much like DNS, you want health checks. And Nginx actually already does this for you automatically. But in the next post there, it talks a little bit about those. With the open source version of Nginx, they're considered passive health checks, but you can do some configuration in terms of defining how many times something should fail, what's the failure timeout. But it does it for you automatically. And if something is detected if the backend is not responding, it'll bring it out of rotation for failure purposes.
That's cool.
Okay, so that's your web server talking to your application servers. So let's talk about, all right, you're going to want to have multiple application servers, and again, across availability zones. Now, when you do this, when you break it out from a single server, you need to be cautious that you're not doing any file system writing on your application, because now suddenly you may be writing to different applications, or depending on how you have it structured, but you may have a request come in and it goes to application server A, maybe you write a file and then you want to read it, but suddenly you come into application B, well, now you're kind of hosed. So you're going to want to use other solutions to do things like caching, or if you're actually saving files out to somewhere. Like if you're on AWS, you're going to want to save them to S3 instead, or some other kind of file storage system. There's open source ones available, but you need a common file area to store it.
Right. Same kind of issue with things like databases and background worker queues and things like that. You need to make sure that you're thinking about, hey, I may have different servers talking to these, so they need to be somehow centralized.
Yeah, so yeah, but the file system's a little bit different for the application servers, because sometimes it writes to it. So you want to be sure not to do that, but use something else. Now, in terms of caching, the two solutions I've heard people use the most is either Redis or Memcache. So now if you're talking about caching, you're going to want a redundant infrastructure for your caching. Now, Redis, I'm not really using it for my app that much. I use actually different processes to run things. I'm not using Redis inside Kick like most Rails apps do. So for me, the easiest thing to set up was Memcache, because that's super easy to set up in a cluster. So basically I set up 3 Memcache servers across 3 availability zones, and my my application servers talk to those and cache things there. So that's working fine for me. All right, so that's how you can handle redundant caching, redundant files. We talked about having a file service like S3. You could also choose, again, use an open source solution, which maybe those are NFS volumes or some sort of shared file storage area. That's another option if you want to do that. But the next consideration is databases. So I'm going to focus mostly on Postgres because I'm a Postgres guy and consultant, so that's what I use. Now, Postgres, oh boy, I'm going to sneeze. Excuse me.
Don't do it.
Maybe I will, I don't know. Anyway, so Postgres does not have a multi-master capability or a bidirectional capability. So basically you have a primary database that's the one you read and write to. You can have replicas, and they're essentially read-only replicas. And then you can promote the replicas if something happens to the primary. So with that scenario, you can't really have active databases ready to go. But one thing I have done to my application servers in terms of talking to the database servers is that I do have a primary database, and I do have at least one replica, and you can have more replicas if you want. What I've also done to make a transition easier, because like I said, you can, if there's a failure, you can promote the replica to be a new primary, is I actually set up at my application server to have a multi-host connection string. So this is a feature that's been added in the last few years to Postgres, where you can actually specify more than one host that your database client, which is the application server, can talk to. So if you look at the next post, this talks about the actual patch that adds multiple hosts and connection strings. So you can put commas between the different hosts that you want to contact, including different port connections and everything. And similarly, when you're configuring multiple hosts, there's another configuration called target session adders or target session attributes, and that defines how you want it to connect. So if you go to the next post and scroll all the way down to the very bottom, this target session adders talks about all the different ways that you can configure how it talks to it. Like you're allowing it to talk to any database connection. You're only going to let it talk to a read-write connection, only a read-only connection. You're only going to talk to the primary. You're only going to be talking to the standby, and prefer standby. So there's all sorts of different ways that you can configure how it's going to make the connection to your database. So I have that set up on my application servers just for convenience, because if I promote a replica, I don't want to have to deal with, it should automatically flip over the application to still read and write to the database, because it'll see the new replica, notice that the old primary is no longer available. All right. Now, I should say that you can set up an automatic failover of the database, but it's actually super complicated and error prone, and there's a lot of additional software that you have to implement for Postgres to handle automatic failover. So I actually still rely on a manual failover process because there's all sorts of considerations with running into split brain issues and a lot of issues with that. So you can do automatic failover. It just takes a lot more work to do. And then the other thing that you mentioned, of course, if you're going to be doing this, you're going to want to have the ability to run multiple background workers like sidekicks, jobs, or multiple job servers to handle jobs, to handle redundancy that way too. And since that relies on Redis, you're going to need a redundant Redis infrastructure too.
Right.
But the great thing about these platforms as a service is they do give you the ability to have some of this just by paying some extra money to use their services and unfortunately get locked into their solution to a certain extent.
Right.
But some of these techniques and some of the links that I proposed are ways that you can roll your own in a platform agnostic way, give you some more experience and maybe save a little bit of money. That's why it's on the cheap, but it's not necessarily wise to always do that.
Right.
And you can always do a hybrid solution. Like you can use some of the services of a platform provider like AWS and do some of your own, things.
Yeah. So, one of the things when you started this, you said it's not rocket science. Sounding a whole lot like rocket science to me. There's a lot of moving parts here. So how do you break this down?
They're just one or two configuration lines that you add. Like, for example, DNS routing. I mean, that's still you go in, you set an additional domain. Once you look at it, it's not rocket science.
Yeah.
Like for DNS, you go in, you just add the same name twice. You say, I want weighted routing, put your weights. Then you got to configure the health checks, so there's a few more things to do. But once you do it, it's like, okay, that wasn't hard. That didn't hurt that bad.
Right.
When you're talking about Nginx routing to backend servers, you just add another line and it will start sending it to it.
Right.
Now, if you want to get more sophisticated with some of their different routing protocols, then it's going to be a little bit more difficult.
Right. So Mark Clifton says, instead of replicating on the component level, it may be simpler to replicate on separate cluster registering to a round-robin DNS, provided your app can handle consistency issues. See, I'm not an infra guy, so that sentence just blew my brain apart. Why don't you respond to that? Give us more, Mark, and welcome to the show, by the way.
I guess I'm interpreting component level, like not making redundant each component. That's my interpretation. Like making Nginx, like maybe you have two servers that are running Nginx and an app server. Yeah, they'd still have to talk to a database.
Yeah, see, if I was approaching a project like this, so component is like DB, Redis, app proxy, Ruby instances, right? Yeah, so each of the little bits that may be true. The way my brain works, I would actually take this, say, hey, I've got to have all this redundancy. Let me start with the database. Let me figure out how to make the database redundant and get that project done. Then move on to maybe the Nginx server, my web server, figure out the redundancy there, and break these down into little bite-sized chunks.
Well, that's what I tried to do.
Right. No, but I'm saying if you look at that in an aggregate way, you go, oh my God, this looks like rocket science. But if you just look at each one of these things and take each one as a project in and of itself, none of them by themselves are really that big of a deal.
Yeah. And I described it from outside in or
Mhm.
top down, depending on how you want to do it. But really, the implementation would probably be easier bottom up. So you start with a database, and
Mhm.
then you allow your one application server to be able to talk to the primary or a replica.
Right.
And then you go up another level and say, all right, I want to have multiple application servers. I need to make sure there's no file system writing. I need to handle caching. Oh crap, caching. All right, let me implement memcache in a clustered fashion. Get that done. Again, you always have one application server.
Right.
Once that's up and running and working, then you say, all right, I'm going to add another application server. That shouldn't break anything. If that works, then all right, now I'm going to have, Nginx that sends traffic to both, etc.
The hard part is with the database in separate clusters, you have the multi-master issue, but if you control the whole stack, you can code your way around it. Distributed is hard, but more resilient. Yes, but it's harder to think about too. And the other issue is as your app gets bigger and your organization gets bigger and your team gets bigger, it's harder to take that as a holistic chunk. Because like in my situation, because we've got an app or many apps that are that are global and multi-user, and we have many instances of them, what we have to do are things like, okay, let's make the database redundant. Let's add some redundancy there and let it sit in production for a little bit and settle before we go changing any other variables. Because if we did it all at once, there's way too many things to try to troubleshoot if an issue comes up because it's so big. So that's not as big a concern if the app or the customer base is a little bit smaller. But when you're talking about hundreds of thousands of users across distributed systems that are worldwide and stuff, you also have to think about, okay, what impacts am I going to have on not only my customers, but on my ability to troubleshoot issues that come up in this system. And that's one of the big reasons why my brain is trained to, let's look at this small little piece and get that working and make sure we don't have any issues there, and then move on to the next piece.
And if you take that bite-sized approach, again, this is not rocket science. It's just a few, like multi-host connection strings to the database. You just add a comma and then add another host.
Writing tests for all the failure scenarios. Yeah. Yes. I mean, you guys.
That's why you have the health checks.
Right. Some of this stuff is not like writing automated tests is almost impossible for some of these types of things, or it's not worth the time to write automated tests for some of them. And you guys who have listened to the show know how I feel about testing. I am on my soapbox about it all the time. But if you don't have dedicated test QA departments or people that can deal with that stuff, and that's what they do, it's hard to automate the tests of this stuff. And even if you do have QA departments for those, which we do, it's still easier and safer to take a bite, let it sit in production for a while. Because even if I were to write all these tests, I will never think of every scenario, and I will never be able to test it the same way that my customers will test it. So, but yeah, writing tests for all these types of things is, at one time, is a pretty monumental task.
And I actually never write infrastructure tests. I rely on services to test the infrastructure. Mm-hmm. So for example, the health checks for Route 53 only check that the web server is working. It does nothing to test that the database is working, that it touches the application server, nothing like that at all. So if I get a failure with a Route 53 health check, I know there's only a problem with Nginx. I have another service that calls my application and goes through all the way to the stack to the database to return the correct value. That's another service that does that. So I'm essentially, that's an infrastructure integration test, but I also have unit tests or component tests, whatever you want to call them, the health checks to say, all right, is this working? And Nginx is specifically testing, is this app server responding? And if not, takes it out of rotation. So that's what I use for making sure the infrastructure is working.
Right.
As opposed to actual tests.
And, infra tests are automated infra tests are a lot harder to develop than like unit tests, RSpec and stuff like that.
Although I have seen some services that do it. So,
oh yeah, absolutely.
But basically you code in something to equivalent to a test into their service, their application, and they hit your app and expect it to go through a sequence.
Right. But because there's so many moving parts and things like this, especially when you start doing the redundancy, and you've got all these different servers, making sure that you're testing all the scenarios and the edge cases and stuff gets really complicated. And you could do it with like the services or things like JMeter and things like that. But man, even basic JMeter tests for a system that gets distributed like this start getting very, very long.
Well, I mean, I look at JMeter as a performance tester, not as a...
It can be, but you can also use it for things like this. I wouldn't use it for things like this on really big applications. There are services that will do a much better job at that level than JMeter, but
yeah, I mean, I guess you could, set it up to do that, to run through particular, because all it does is run through scenarios.
Right. You can, and I have seen people do that. We have some tests like that internally, but we only use those for like internal server stuff, not production client facing things. We use those for like preliminary testing rounds on internal things. I've been implementing health checks via Prometheus metrics. It's a nice way to keep history and ordering when multiple failures happen. I've heard of Prometheus metrics, but I've never used Prometheus myself. Something I'd be interested to check out. Again, I'm not an infra-side person, so infra-side. I kill all the servers. No, infra-side. I may be an infra-side person, CIDE. I have killed servers in my time, but yeah, and there are services out there that can do this stuff. It's really hard to get a handle on the whole ball of wax, because there's a lot of moving parts in infrastructure, and they can get really big and complex. Like our infrastructure diagram at where I work is enormous. We actually blew up one diagramming program that tried to do it. It was bad. So, whew.
Well, speaking of Prometheus, I have a client that uses it to monitor their infrastructure. So it's on my to-do. I actually want to move to using it because right now, because that brings up another point about this redundancy is logging. Because when you have one server, you only have one place you have to go. You can look at the database logs. You can look at the application logs. Mm-hmm. You can look at the Nginx logs. You can look, all the caching, all the logs are on the one server. And you can just go grep different directory log files and you can figure out what's going on. Once you go to distributed infrastructure, it's like you can't go into a server and then figure it out. You got to be collecting those logs, putting them in a common place to be able to search across them to figure out, all right, what's going on with a particular issue. So logging becomes immensely important. Now, so basically, that is a solution that you're going to have to figure out as well if you're going to be moving to this, how you're going to be doing logging.
Yeah.
Along with logging is also monitoring. And like I have a client that uses Prometheus for monitoring, CPU stats and disk and memory, as well as relevant statistics with regard to their database system, the queue sizes in their jobs, the Nginx metrics, the app server metrics, everything is in Prometheus. So it basically is a way to collect all of those metrics. And then typically Grafana is a graphing program and use Grafana to graph it out. So that's on my to-do list. I would like to move to that because currently I'm using AWS's monitoring and logging stuff.
Mm-hmm. Yeah, and logging aggregators are very important, and I use those all the time because we have such a huge distributed system. When we have multiple servers running our different apps at any one time, and they all talk to each other. So log diving is a significant portion of what I do, and it would be impossible without a log aggregator. And we use Datadog. We used to use Grafana, but we've migrated over to Datadog. But even then, it's hard to track that stuff, and you have to start being really careful about what you're logging in your program to make sure that it can help you track down issues when you go log diving.
I haven't actually seen anyone use Grafana for log aggregating.
Well, which Grafana are you talking about? Because there's a service called Grafana, Grafana, that does log aggregation.
What was the name again?
Grafana, Grafana.
That's what I'm talking about. That well, they're calling it an observability platform. I just didn't know it. Well, it says it does logs. Yeah. I've mostly seen it in use for metrics. I haven't seen it do log stuff.
So, Grafana has alerts now. Aggregate logs via Loki. Yeah, that's what I was primarily in, was Loki. Then build metrics out of the logs, and it is a rabbit hole. Personally, I wasn't a big fan, but it does log aggregation.
I wonder if that's a new feature, newer feature. I don't know.
But yeah, we've kind of migrated away from that into Datadog. But some kind of log aggregator is necessary when you start doing stuff like this. You just have to have it. So
and the metrics too. So you can,
Yeah, for sure. I mean, APMs are essential when you get into this stuff as well. Which for us, Datadog is the APM and the log aggregator. It's kind of the one-stop shop. That's one of the reasons that we migrated to it. Cheaper alternative than Elk. Cheaper? I thought Elk was... Isn't that open source? Am I missing? Or are you talking about a service? I don't know. Maybe I'm missing. I haven't used Elk for a long time. It's probably been 6, 7, 8 years since I've dealt with an Elk server.
I thought it was open source too, unless they've started charging for stuff where it's
could be, or it may be that because Elk has more resources. Okay. Yeah, because they may have started charging for doing like a SaaS setup, but when I was doing Elk, I was always setting up my own Elk servers and pointing to them. But so, Mark, are you more on the infra side or the engineering side of things? Because you're doing a lot of infra talk here, which is blowing my mind.
He's an infrastructure engineer.
Yeah, well, I should say the coding side. But But yeah, this is I was always intimidated by this kind of stuff when I started looking at it. You wear all the hats, small company. Yep, I know that feeling. I came from small company wearing all the hats, and Creston is small company wearing all the hats, so we're familiar with that. So yeah, that always intimidated me just because it's such a big topic, and when you look at it holistically, it's like, oh my God, there's so much stuff you have to know about and learn and figure out and all. But if you just bite it off one little chunk at a time, it's not that bad.
Yeah. And I was first a systems administrator. Then I was a database administrator. Then I, did some other things and got started doing more programming and whatnot. So I kind of have been doing this for many, many years. So to me, it's not rocket science, some of it. I mean, things change awful fast, like Kubernetes coming on the scene and pods and all this kind of, I haven't even looked in that direction.
Right. Well, and it
But
is.
a
I
lot
mean,
of
it's
this
a
stuff is
huge
just
landscape.
open source software that you add additional. It's essentially adding one or two lines or modifying a line that already exists to talk to more than one database, to talk to more than one application server, to talk to more than one, web server. So in the end, yes, it does take some research to understand, but actually doing it, there's not a lot to change to do it.
Right. Yeah, I think the biggest hurdle is just figuring out what you can do. Not the how to do it is usually fairly simple, like you said. But what can I do? Well, actually a lot.
Well, I mean, it's just having two or more of different things across availability zones.
Right. Well, yeah, true. But two or more of databases and Redis instances and so yeah. But
but when you start counting, it's two. It's I got to do two of this. I got to do two of that. I got to do two of whatever. So you're going from one server to now we're talking about 2, 4, 6, 8, 10. 10 plus servers. So your infrastructure has become significantly more complex.
right. And for the love of all that's holy, when you start getting into stuff like this, do yourself a favor and document it. You don't want to rely on your memory 6 months down the road when you've got 24 different servers all talking to each other.
No. You use Terraform, Ansible. It's all code.
But that's still documentation.
And that is your documentation.
Right. But don't just go set up servers and do your little setting in Linux that talks to this thing and then no. Don't do that.
You can't do that.
That might work okay for one server, but as soon as you get another one, you need to start thinking about automation and documentation, or you will just kick yourself 6 months after you set it up. I can promise you that because I've done it too many times in my career to still be considered sane. So just don't do that. All right. That was a show. Oh my goodness.
You can tell where Chris is uncomfortable with the topic of the evening.
Yeah, infra is not my thing, dude. Yeah, I'll just, I'll stick to the development and project management stuff. I'll let you handle the crazy people side. So, but yeah, it's important for people to know this stuff though. Even if you're just a developer and you're in a big enough company that you have a whole infra team taking care of this, it's still kind of important for you to understand what's going on in that environment, because a lot of times the stuff that you're writing has to be able to fit into those frameworks. And so if you don't understand it, you don't understand how to develop things that will work properly in there.
Yeah, I mean, you got to understand your utilization, where things are slow. You got to be able to interpret performance graphs and say, well, why is this happening? You may have an infrastructure guy at your side helping you out, but the more knowledge you have, I think the more effective developer you can be for your infrastructure.
Right. And Mark Clipson says, don't over optimize. Absolutely. Redundancy has a high complexity cost. Single point of failure can be okay. Actually, I would say single point of failure is preferred. Sometimes the business needs to permit some downtime. Oh, yes. And that's a constant struggle between the engineering side of things and the sales and marketing side of things. So, yeah, that's a tricky political football to have to kick, but you have to do it. But yeah, and when you talk about single point of failure, I would define that as single avenue of troubleshooting that I have to go down. But what I don't want is my customers to suffer because I didn't put in the time to put reasonable redundancy into my product. That I think would be a mistake. I don't want something to fail just because I only have one of them. Because there's always going to be a case where, somebody kicks a cord out. It just happens. I mean, stuff happens. We've had cases, Amazon goes down sometimes. The S3 bucket goes down sometimes. And if you don't have redundancy, if we didn't have redundancy in those cases, we would have lots of upset customers. And it would cost them a lot of money if that happened. And consequently cost us a lot of money. But I do agree that being able to troubleshoot those things quickly needs to be thought about as far as simplifying the architecture so it's not so complex that nobody can troubleshoot issues with it. That's not good either. So lots of stuff to think about. Thank God I don't have to in my current job. Yay me. All right. So hope you guys enjoyed that episode. Thanks for joining us. Thanks for the discussion. It's always fun. If you enjoyed it, please don't forget to like and subscribe or follow if you're seeing this on Twitch. Just mash all the buttons and ding all the bells. Join us every Wednesday night at 8 p.m. Eastern for more dev talk. Tell your friends. We know you have some because you're lovely people. Next week, we have no idea what we're going to talk about yet. We will figure that out. And if you want to know what it is ahead of time, you can follow us on Twitter at @DuckyDevShow. I will announce that at some point between now and 8 o'clock next Wednesday evening. It'll probably be about 7:50 next Wednesday evening because I suck at Twitter. If you have a topic you'd like to see on the show, please leave it in the comments below. Podcasts are available everywhere that podcasts live, and you can visit our site, rubberduckdevshow.com, sign up for our newsletter, and find all our videos and podcasts there. Thanks to Creston, who does a lot of work putting those things up. And no thanks to YouTube, who for some reason in the past couple of weeks has screwed up the ability to download the thumbnails. So, in technology, wonderful. Anyway, hope you guys enjoyed that. We will see you next week. And until then, happy programming.
Happy programming.